Hello students, in this video we are going to see about how to create subnetworks in Cisco Packet Tracer. Let's start with this problem. They have given the address 192.168.1.0 and they asked to create subnetworks and configure it. So whenever they are giving the subnetworks, first we have to find the subnet mask. Before going to calculate the subnet mask, I hope you would have identified the given IP belongs to which class. Yes, the given IP belongs to class C. How I'm telling this? Yeah, that's a simple logic. So whenever the first number starts or between 0 to 127, the given IP belongs to class A. Whenever the number is between 128 to 191, it belongs to class B, and 192 to 223 belongs to class C. So this we have seen in our earlier videos, how we can identify the class of the IP by looking at the first number. So it belongs to class C since the first number is 192. And what is the subnet mask? Here subnet mask means default subnet mask for class C. How we can calculate the subnet mask or default subnet mask for a particular class? For that we should know what is the net ID length of the particular class and host ID of the particular class. So this is class C. Class C's net ID length is 24 bits and its host ID length is 8 bits. So this also we have covered in our last video. So if you are having any doubt, please go through that and come back here. So net ID length is 24-bit, host ID is 8 bits for all the class C addresses. And to calculate the subnet mask, we have to enter 1 for the entire net ID length, and for the entire host ID length, we got to put the value 0. I'm going to do it. 1, 1, 1, 1, 1. So first 8 bits 1, the next 8 bits 1, the next 8 bits 1. So totally 24 bits for the entire net ID 24 bits. I have entered the value 1. The remaining 8 bits are host ID part. For that I have to put 0. Okay, so this is the subnet mask or default subnet mask for all the class C addresses. If you are converting this into decimal notation, it will be 255.255.255.0. Okay. But now we are using CADR notation. CADR means whenever they are giving the IP, along with it slash, if they are giving some number, they are using classless interdomain routing. So whatever the subnet mask, default subnet mask for class C we have calculated, it is not applicable for CADR, classless interdomain routing. So again we have to calculate the subnet mask for the given IP. So here is a small numerical. You just look at the number 27. 27. Okay. 27 ones. Okay. The 27 represents the network length. So put 27 ones. Okay. So this is as usual finding subnet mask 24 bits 1, but now they have given the number 27, so 3 more ones we got to enter, and all of the remaining numbers are 0. So what are the remaining numbers? 5 zeros will be there. Now we got to calculate the subnet mask, the decimal notation of the subnet mask. So first 3 numbers will be as it is 255, the 255, the 255, because there is no change in the first 24 bit 1. But here the last 8 bits there was a change of value. The 3 zeros become 3 ones since we have extended the net ID length. Now what is the last value? To calculate this, let's go for this. So 3 ones I have written, 5 zeros are there. convert this number into the equivalent decimal notation, it will be 224. You please do it once, then only you can understand. Okay, so please follow this conversion. We will be getting the number 224. That is what I'll be writing it here. So now the new subnet mask for this given IP is 255.255.255.224. So where you got to careful means whenever you are setting the IP, whenever you are setting the mask address in Cisco packet tracer, by default this number will be taken for all the class C addresses. But now we got to convert this default number into this. So let's see in the Cisco packet tracer, okay, when you are configuring the subnetworks. So this is the first step. First step is we got to calculate the new subnet mask. The next, we got to find how many number of subnetworks we can create and how many number of hosts can be part of each subnetwork. So when compared with the default subnet mask, how many number of bits we have changed, or how many number of bits we have borrowed from host part to net ID. The first 3 bits we have borrowed. Okay, so 2 power 3. 2 is a binary number. Since we are using the binary notation, I'm using the base 2. 3 is the 3 number of bits I have borrowed from the host path. So 2 power 3, it is equal to 8. So 8 subnetworks can be represented or configured for the given IP. And finding the number of hosts. So 32 is the entire length of the IP address. 32 minus 27. 27 bits now becomes a part of net ID. So 32 minus 27, the number is 5. So 2 power 5, that is equal to 32 host. So 32 computers, 32 IP addresses will be part of each subnetwork. So this calculation we have to do, and this is the step 2. Step 1, we are calculating the new subnet mask. Step 2, we are calculating the number of subnetworks and number of hosts we can configure for each subnetworks. Step 3. Okay, so we have calculated this to be 32 hosts in a network. So since we are starting from 0, it will be up to 31. The next starting address is 192.168.1.32. 2, another 32 systems you add, 32 IP addresses, 1 dot, so it will be 63 since you are starting with 32. 192.168, 1 dot, from 64 we have to start, so 192.168.1 dot, so it will be 96, so 95. Okay. Since you are starting from 64. Next one, 192.168.1.96 to 192.168.1 dot. So it will be 126, 128, 127, 192.168.1 dot, 128 to 192.168.1 dot. So it will be 160, 58, 159. So 192.168.1 dot 160 to 192.168.1 dot 191. 1 dot 92 to 192.168.1 dot this will be to 23, 68.1 dot 224 to 192.168.1 dot 255. Okay, so now 8 subnetworks we can create, and for each subnetwork we have found out what is the starting address and what is the last address. So within this range only we got to give the address for each subnetwork. And always the first address, the starting address what I have mentioned will be the subnetwork address. Each subnetworks now need an address because uniquely we have to identify out of 8 subnetworks to which subnetwork we are going to send the packet, we are going to send the data. So each subnetwork now need an address. So the first address we are dedicating to the network, so it becomes a network address. And always the last address in the subnetwork will be the broadcast address. Nothing but in the particular subnetwork, when you want to broadcast a packet, when you want to send a data to all the systems in the subnetwork, we'll be using the broadcast address. So the last address becomes a broadcast address. The first address becomes a network address. Remaining, how many IP addresses we are having? We are having originally 32 IPs. So in a subnetwork, effectively we can connect 30 systems. It is applicable to all the subnetworks. So each subnetwork effectively it can have 30 hosts, though 32 IPs are available. Okay. Thank you.